Hi guys, how you going? Welcome to the first of three videos on Newton's laws. And we're going to start with Newton's first law, funny that, and this one's also known as the law of inertia. So Newton's first of the three laws of motion describes how a moving object will only accelerate if an unbalanced force acts on it, or if there are no forces acting or the forces are balanced, then the object will continue with its original velocity. Now that all sounds a bit strange, so we'll delve into what that actually means. We've got a precariously balanced rock here. This rock is quite large, gauging by the people that are kind of standing near it. Now at the moment, the forces acting on this rock are balanced. So you've got a force of gravity acting in a downwards direction. So that's causing this rock to kind of weigh or press down on this bigger rock underneath it. But that rock is also exerting a force in the opposite direction, going upwards. So it's large enough to be able to keep this rock from not falling. So at the moment, all of the forces acting on this rock are balanced. And that rock is not going anywhere. Okay? So that object will continue to stay where it is. If a force comes that's strong enough to unbalance those other forces, then that rock might move. If you got some ridiculously big machine and you went behind this rock and pushed it, that would exhibit an unbalanced force on that rock. And if the rock isn't big enough to exert the same force back, then that rock may start to move. Okay? And once it moves, it's probably going to fall down. And the only thing that will stop it is when it hits the ground. So inertia. All objects possess inertia. This means they do not like change. Objects don't like change. People don't like change either. They keep doing what they're doing, or they keep on doing what they're doing, sorry, unless it's acted on by an unbalanced force. That's how I want you to remember inertia. Objects keep on doing what they're already doing. Objects are lazy. Objects are lazy. That is inertia. Now I'm going to go with the Pokemon theme here. This is the laziest Pokemon I could think of. Snorlax is very lazy. He just kind of sits there and sleeps, I think. I'm not quite sure what he does, but he's lazy. I know that. Look at his eyes. They're lazy eyes right there. The formal definition of inertia is this. This is the one that I learned when I was at school. Objects at rest will remain at rest, while moving objects will continue moving at a constant velocity unless acted on by an unbalanced force. Can I please get you to pause the video and record that formal definition down in your books. Now, the larger the mass of an object, the harder it is to change its motion because it possesses more inertia than the object with a smaller mass. So basically, the heavier something is, the more inertia it has. So the lazier it is. Okay? So a reasonably small object like Jigglypuff, I'm just going to stick with the Pokemon theme. So Jigglypuff's pretty small, I think. So if we wanted to move that Jigglypuff, say, I don't know, kick it like a football, it wouldn't take that much force to actually start moving it. But what if you had a bigger object with more mass, like our old mate? To move him would require a considerably larger amount of force. Okay, so it's harder to change the heavier object's motion than the lighter object because the heavier object has more inertia. But by the same token, once that object starts moving, say it was rolling down a hill or something, it would take a lot more force to stop that object than this object. A few everyday examples of inertia. I'm not a huge fan of catching the bus. I had to do it for many years at university. But when you're on the bus, sometimes you have to stand up because you other people take your seats. So you're standing up and the bus starts moving and you're moving. I just realized that this is a tram. It's the same thing for the purposes of this explanation. So you're on the tram, you're holding on, and the tram is moving, and then it stops quite suddenly. Maybe a person just ran in front of it and the tram driver's just put on the brakes. Now the tram is going to stop really quickly, but what's your body going to do? Your body is still moving at a constant speed, okay? So you're going to fall forwards until an unbalanced force stops you. Now that unbalanced force might be your arm holding onto the railing, it might be a seatbelt if you're in a car, but you will have noticed that before. The object keeps moving and the unbalanced force stops you. So that's an example of inertia happening. If you love your tomato sauce and you've got a little bit stuck on the bottom, what do you do to get rid of it? You turn the bottle upside down and you kind of shake it really fast. So when you're shaking it downwards, that tomato sauce bottle is moving and it's providing a force to the tomato sauce at rest. And then that will move, and then once it hits the side of the bottle, then it will stop. That's your unbalanced force. And there's many, many more examples of inertia in everyday lives. I just like tomato sauce, so that was just the most relevant one to me. What I would like you to do, is to provide 2 examples of your own where an object experiences inertia. You can look them up, you can make them up, try and be creative with it. And I'll have a look at your answers next lesson. Thanks guys, see you later.